In this video, we're going to discuss the key features of a quadratic function or of a parabola, the graph of the quadratic function. A second degree polynomial, for example, x squared plus 2x minus 8, is a quadratic polynomial, which has a related quadratic function f of x equals x squared plus 2x minus 8. A quadratic function is an equation of the form y equals ax squared plus bx plus c, where a does not equal 0. The graph of a quadratic function is called a parabola. Both of those should already be in your notes from the vocabulary video. So what we have a graph here, let me make this bigger, of a parabola. A quadratic function is graphed here. And I'm going to click on each of these key features and get some more information about them. Feel free to pause the video so that you can copy this stuff down as we go through it. So the first one is the axis of symmetry. Okay, the axis of symmetry. Parabolas are symmetric about the center line called the axis of symmetry. Every point on the parabola to the left of the axis of symmetry has a corresponding point on the right half. The function is increasing on one side of the axis of symmetry and decreasing on the other. Okay, so the axis of symmetry, that is the line that cuts your parabola right in half. Right, so you have this nice U-shaped parabola, and the axis of symmetry chops it right in half. So, like there's this point here at 0, 0, and then a point corresponding at 2, 0. Right, they're the same distance from the line of symmetry. Vertex. The axis of symmetry intersects a parabola at the vertex. The vertex is either the lowest point or the highest point on a parabola. So our vertex is right here. It looks like it's at 1, -1 in this graph, right? And it is the lowest point on this graph. Now, had the graph been going the other direction, something like this, right, then the vertex, where my fingers are there, is going to be the highest point. And speaking of vertex, they have maximum and minimum. Okay, and when a is greater than 0, the graph of y equals ax squared plus bx plus c opens up. In this case, the graph has a minimum at the lowest point. So that's this blue one right here. When a is less than 0, the graph opens down. In this case, the graph has a maximum at the highest point. That's this orange one here. The next key feature is intercepts. This graph has two x-intercepts, 0, 0, and 2, 0. The graph also has one y-intercept at 0, 0. Right? One of the x-intercepts is also the y-intercept. Right? So the x-intercepts are where it crosses the x-axis. The y-intercept is where it crosses the y-axis. And the last key feature is the end behavior. The blue curve opens up and has a positive leading coefficient. So x increases or decreases, y increases. The orange curve opens down and has a negative leading coefficient. So as x increases or decreases, y decreases. When identifying the key features of a quadratic function from a graph, it is often easiest to locate the vertex first. It is either the maximum or minimum point of the graph. Drag each term to match its graph. Okay, so this one is opening up. So that means that A is positive, and it has a minimum. This one is opening down, so we're negative, and it has a maximum. And for anyone interested, during the 19th century, several designers of the Brooklyn Bridge were unable to complete it, but Emily Warren Roebling supervised the bridge's construction until its completion. The bridge was the first major suspension bridge constructed in the U.S. Its cables form a catenary which approximates a parabola.